Hi, my name is Rebecca Fath. This is my black hole mass video for Lab 7. The objective was, given the star's positions over time, find the net force acting on the star. If the gravitational force of the black hole is the only force acting on the star, predict the mass of the black hole. So I was able to find the net forces acting on the star, and then I was able to calculate the mass of the black hole being 3.58 e to 31 kilograms. So first, we were given a spreadsheet of the x and y position of the star over lots of different times, and then we plugged it. And then we created this code in order to use that information to calculate the net force acting on the star. We plugged in our initial values here of the star mass, and our delta time is going to be 1 day. And then we took out variables from the spreadsheet, giving us two different x's, and then finding delta x, and then creating the velocity, having that being over time. And then I did the same for the y, and then we were able to create a velocity vector, an initial one and a final one, because again we have so many values that we could just keep going on to the next position and then calculate the next velocity. So then I was able to find the momentum, and then I found the change in momentum over time, which gives me this value here. And I know that according to the fundamental momentum principle that the F net is the change in momentum over change in time. Then we also wanted to find the change of momentum, change in time in the parallel and in the perpendicular direction. So first I found P hat, P final over magnitude of P final, and then I found the magnitude of dp dt in the parallel, which is the magnitude of P final minus magnitude of P initial over delta t. And it's important to do magnitude of P final minus magnitude of P initial and not magnitude of P final minus P initial, because those are two different values. And then I was able to find the parallel component of the change in momentum or change in time by multiplying P hat times this magnitude. This value is also equal to the F net in the parallel direction. And then since the total dp dt is equal to the perpendicular and parallel components, I just subtracted the parallel component from the total in order to get my perpendicular, and then the F net perpendicular is again equal to the dp dt perpendicular. So then we use this, and you can see the code run. And here the red arrow is the force in the perpendicular component, and the black arrow is our F net, and then our blue arrow is the parallel component. And you can see that it's moving in an elliptical form because that's how the gravitational force, the only force acting on this star is the gravitational force given by the black hole. So then when this was running, we also asked it to print off all of the forces, the net forces acting on the star at the different times, and these are these blue values here. In order to calculate the mass, I'm going to take this first F net, and then I'm going to take the second values here of the positions, just because since it's P final minus P initial, so we're going to take the second one because that's how we're going to use the first one here and the second one there. And then down here, you'll see how we calculated it. So our star is again that position, black hole was given to us, then we found the distance between them, then I found the magnitude of that distance, and then since the gravitational force is the only force acting on it, so F net equals F grav, which is this force, again, found from our code. Found the magnitude of that. And then I used this equation, F grav equals this constant g times m1, m2 over the magnitude of the distance between the two. So I rearranged it so that I isolate the mass of the black hole, and I plug in these variables, and I got a mass of 3.58 e to the 31 kilograms. So what does it mean? So this is talking about comparing the change in momentum over time and the F net. As I showed you that this is the total F net and this is the perpendicular and this is the parallel forces. The difference between, although the F net and the change in momentum over change in time is equal, the values are equal according to the fundamental momentum principle, they're actually not the same thing. The change in momentum or change in time is this calculation based off of the position of how the how the position changes of the object, whereas the F net is the sum of the forces acting on the object. So those, and those are the same value, what they actually are two different things. So what if you imagine a black hole whose mass you found was replaced by a different black hole, but still is placed at the same location, and that the star's positions don't change at all? We could not be able to tell the difference because the new black hole would have to have the same mass as the old black hole, because the gravitational force is the only force acting on the star. And so you would have the same forces acting on it continually, meaning that it would have to have the same mass, because as we saw in this equation, it can only have one mass. That's not going to be able to change if it has the same force acting on it. Thank you for watching this video.